Let's see if my internet will work today, because yesterday it was dropping frames like crazy, and it looks like it is working. Is that set on public? Yep. So we're good to go. Let's grab a MacBook. So the first one I'm going to be looking at is going to be, it looks like an A1286 that does not turn on. So let's confirm that, because we can never trust what something says before it comes in. Because half the time, something will not turn on, and this is an A203330, and I already see our problem. There's actually no need to test why this won't turn on, because I see the hole in the ISL. So there's really no need to take this apart, or no need to test this, because we know it has a hole in the ISL. So here's the thing about your ISL. When it has a hole in it, it's no good. So let's take this apart. So this is a T6, not a T5. And we'll also need a Phillips for this little shield, and I also will need a screw holder. We can use this one. So take off this little shield first. Yeah, our ISL has a nice little hole in it, which also means Q70 30 and 35 are going to be bad. Can't really see those that are visually bad, but we know it's bad if the ISL has a hole in them, because the ISL controls the switching to both of those, and the SMC may also be bad. That may suck if that's the case, because I don't have an SMC for this because it's so old. That will make me sad. That will make me very, very sad. I really hope the SMC isn't bad. Usually that happens when someone's changing the battery and they short the data lines to that. Hopefully it's not that. And it's very warm in here. I should probably turn my air up. My air is on like 75. I should probably put it down to 68. But being 68, that means my electric bill will go up. And I don't want my electric bill to be $700. $700 electric bill is not fun. $700 electric bill is sad. The board is almost out of the enclosure. Almost there. Almost there. Here's our motherboard. Let's look at it under the microscope now. So here's a microscope view. Now Sarah's here. Where's Stella? Stella's at home. I'm going to bring her to work this weekend, I think, and I'll do a stream. Okay. I will work for free for you. That's okay. So, here's our ISL. And what do you see? What do you see? You see a hole, and now a hole right there is not good. Now let's see which pins those. So that looks like just current sensing, and that current sensing resistor has a hole in it. Maybe this survived. Let me see, just for the heck of it, what our SMC data lines are, if they're shorted or not. So an 820-3330, 33-30 or 820-3330 is a 2012. 81286, very similar to the defective 820-2915, only this is almost an identical board, except it uses a NVIDIA GPU that does not die. So let me open a board view for this. This is probably one of the most reliable boards that I see. I've only worked on a few of these, and they really don't die. They don't die very often, I should say. This is a pretty stable board, and if I absolutely had to have a MacBook and there wasn't any other options, I'd probably choose a 2012 81286. Alright, board view, open, and rotate so it's the right way. I'm gonna bring my assistant to work this weekend. Okay, so the resistor that blew, R70001, which is right here. This is for PP5V1 charger. So most likely the regulator for that's going to be trash. Our data lines, which are going to be on pins 10 and 11 right here, so the third and fourth pins in, I want to check these for a short. Hopefully these aren't going to be shorted. If these are shorted, then that's bad news for our SMC. So that looks like both these are going to, it's going to go to these two resistors, and that is right. I'm going to check both of these for a short to ground. No short. No short. So there's a good chance our SMC is just fine, which means that you won't have to see me replace an ISL. Is that lane obstacle also holy? It looks like it. How does a hole in like this happen? So typically on this chip, usually from plugging in the battery with, like I said, with what happens is you'll short the 18 volts, the SMC data line, but what I think happened here is the 5V1 circuit failed and actually sent 16 volts to the part of the chip that was expecting 5 volts and blew it up. So typically, yeah, that's how it happens. So if we look at our 5V1 circuit, I bet that's going to be bad too. And I'm going to kick on my fume extractor. So let's look at our 5V1 circuit. So where does that show up? PP5V1 charger VDD, or whatever that's called. Let's look at the schematic, because I can't tell from here. And that is going to come, let's see, we have to trace that back more. Paul, your software isn't scrolling. Why is the software not scrolling? Alright, so let's look at the schematic here. Is this one of the weird ones that doesn't have a generation circuit for that? Maybe. Maybe it's just done with a voltage divider. Either way, let's go ahead and start removing all this. It's also possible the ISL just... Here's another really good possibility, is the ISL just shorted and blew that resistor. So that's also a good possibility. So let's start. Let's take off all this old junk that's no good. Like, this is no good for sure. None of this stuff is good. I'm guessing we're also going to have a short on PP bus. I could be completely wrong. Just go away. That's welded to the board, and I did something stupid. I did not take out the RAM. That was dumb, but we should be okay. Hopefully, and actually the RAM slot is already broken, so I can't really take out the RAM. Okay, so that was like that. So yeah, so maybe I could take it out. Yeah, I can. Just one clip is broken. The RAM slots didn't get hot enough to damage anything, but it's always a good idea to take those out. So it looks like our current sensing. Usually how this happens, the ISL dies. So what I think now is the ISL died and killed it. Sure would be nice if YouTube didn't take 7 minutes to send notification. That's YouTube. YouTube is lousy. That's how YouTube is. Let's check for a short on PP bus real quick. And there's a dead short on PP bus. So with everything off, let's find that short. It's probably going to be one of these MOSFETs. You know what, I could probably even just go ahead and take these off. Should I? Yeah. I know these are going to be dead. So I'm just going to remove them, because I know they're dead. The pad, yep, the pad is destroyed. So we'll have to run a wire to that trace under the chip, which is always fun. But running a little wire makes it funner. Get rid of these MOSFETs. I replaced these with like 75 or 105 amp MOSFETs compared to the 30 amps they have. And our short is gone. I was 100% right. So these guys are going to be replaced with 105 amp MOSFETs. Much better quality by ST Microelectronics and not whatever Apple used. Apple used Fairchild. There's nothing wrong with Fairchild. I just like these STM microelectronics FETs. Grab my wick. The new editing computer is excellent. I edited that video this morning, and it was amazing not having to bring stuff home to edit stuff. I mean, no taking 5 minutes to render a small clip of video. It's all just instant. It's amazing. And on the plus side, it doesn't randomly freeze and crash and blue screen and do all kinds of other stuff, like the old one did. I don't know why I kept that old one for so long. You know, I should have spent money and got the new one a lot sooner. The audio still clips a little bit, but not near as bad as it used to. So that was part of the issue too, is that on that old piece of junk, something was up. I think it's just the CPU wasn't quick enough to keep up with it. It was a quad-core Xeon, but oh well. Some solder here. Hopefully our SMC won't be dead. I really don't want our SMC to be dead. That would make me really sad. Maybe I'll get lucky. Unless someone comes along and says the SMC is going to be dead, and then, in that case, most likely the SMC will be dead. Almost every time when someone says something like that in live chat, it always ends up being true. See, Nasara's nice. She's wishing good luck. She said no dead SMCs. That's what we want. We don't want dead SMCs. Let's grab some new MOSFETs. These we're going to use. What's the model number on these? So these ones, I think they're discontinued now. But so yeah, I have a huge reel of these. Look at this. Overhead. So yeah, look at this reel. MOSFETs. These are like, I forget how much, but I paid like $10 for this whole reel. Yeah. These are ST Microelectronics ST. I can't read that. ST10. Let me read. ST105N. I'm sure there's some nonsense after that, but yeah, these are good, reliable MOSFETs. We are good viewers because we will lie to you to make you feel better. Thank you. I appreciate you for shattering my hopes. Sarah just took away any confidence I had in this SMC being okay. But that's okay. We will see. Let's grab a donor board. $28.50 the same circuit? No. It's $29.15 is the same though. No, $29.15 is safe in the shop. They're all junk, so we just steal stuff off of them, even if they're working. $29.15 should not be allowed to live. Period. Every single $29.15 on the planet Earth should die. I hate this board. I'm fairly certain this board hates me too. I had one in for something else, and the GPU literally shorted to ground on PP Bus G3 Auto, and I had to replace that board. It was here to have the GPU disabled, and the thing literally shorted to ground while it was here. So yeah, 820-2915s hate me as much as I hate them. Rob is here. Hi Rob, how's it going? $29.15 boards are evil. I suspect that someone might turn off audio. What? No, it's cutting in and out again. It's not auto adjust anything. It does that. Yeah. I've tried everything to fix it, and it does it once in a while. It's intermittent, and it's something I'm gonna have to live with right now. I apologize, but there's nothing I can do right now. If it's bad enough to where it's bothering you, I just suggest hit X and go on with your day. But I have tried everything to fix that, and I can't solve it, so I think it's an issue with either the transmitter or the receiver. But from what I've heard, it doesn't do it as bad anymore. It still does it, but not as terrible. My hands are really not steady today. Look at this. So it's not really the fact that it shakes, right? It's the fact where you try and do something and then it jumps like that. It's weird. Okay, so let's grab my ISL off of a nice donor board. Does this one have it? This does have it. This one has heatsink on it too, and a CPU, which is concerning because it probably has a dead CPU. How bad is that cratered? Is that even cratered? I can't see. That should be fine to run a wire. Run a little nice jumper wire. Maybe this will work. Hopefully it'll work. Rob, is the audio really bad right now or not bad? Okay, if it's not too bad, then I'm not gonna worry about it right now. It's not an auto. It's not an auto adjust. It's something else. I think it's an issue with either the receiver or it could need to be re-terminated. I think the line needs to be re-terminated too, because it is a little bit messed up, and I captain taped it. So I need water. My throat is dry. I have not drinking water today. That's not good. Sarah asks, how big is the nozzle on your hot air? My hot air nozzle is 8.4 millimeters, so let me show you. So that is about that big. So it's the biggest one I have. So it's a good size. I don't like the small nozzles because the small nozzles really don't do that much. They don't preheat a large area of the board, not large enough to. They just take a little bit longer to take stuff off of. So we'll still run a jumper, but we do have a connection there, so that is good. The large ones I have are, hang on, my window's in the way. The large ones I have are square shaped and not with a hole in them. Does the nozzles that your station take look like this? Let me see. Where's my keyboard? No sound? No, I wasn't talking. I see I have sound on here. Let me listen to it to double check, but I'm pretty sure I have sound. Okay, you are trolling, so. Alright, so these are the nozzles I have. This was for my old station. Does the end on yours look like that? This is the one I have. I have a 8, and then I have this bent one that I used a lot. I think that's a 12 millimeter. And then small one, I have a bunch of others. So these are the old type nozzles, and I'm pretty sure it should be the same. Pretty sure on those you can get them from China, like really, really cheap. So I think I'm done here. All these are soldered. Maybe not. I don't like that. I have to redo that. Sarah, send me a picture of the nozzle that you're talking about. I don't think I've seen ones like that. Unless it's one of those ones for doing BGA stuff. I don't know. I'm confused. Alright, so here's our ISL, all soldered. Now here's a moment of truth. Will this work? Will this not work? There's our fan. You can see our fan. Plug it in. Do we get a green light? Please, green light. No green light and no fan spin. Let's see what voltage PP Bus G3 Hot is. It's probably 12.25 volts. No. It isn't. It is 12.5 volts, but no green light, no fan spin. 12.51 volts. So our SMC is actually working. So our SMC is working, but why don't we get a green light or fan spin? That doesn't make sense. Plug it in. There we go. So now we have a green light. So the MagSafe just wasn't seated. So we now have a green light on the charger. So see this, we have a green light. Green light. Spin fan. Spin fan. Oh, those nozzles suck. That's really weird, that nozzle. Honestly, I haven't seen one of those before. Let's see. Okay, so that board is fixed. Show Paul. Okay, so here's this nozzle. Let me pull it up on here. I hate, wait, what am I saying? Alright, 1 second here. Alright, Paul, are you here? Display capture. So here's that nozzle right here. I've honestly have not seen a nozzle like that. I don't even know what that's used for. That's really strange. It's like, I don't see, but the thing is the bracket is the same as the other one, so that should be easy to get new nozzles for. I just haven't seen anything like that. I don't see what purpose that would have. I don't know. VGA maybe? Okay, so this is fixed. It's for QFN packages. I've never soldered a QFN package that I would need that for. So this just needs ultrasonic. This should be good. This is fixed. So this needs Q for ultrasonic. Put that right there. Those are for quad flat packs. What's a quad flat pack? I have to look up what a quad flat pack is. Oh, okay. Still, even those, I could still get those without that. But that, yeah, that's gonna be impossible, and that's not gonna put out enough volume on MacBooks, I don't think. So this one is. Let me put this in a slot real quick. That's not gonna put out a good enough volume to take off a on these MacBook boards because they're so thick. That would work on a thinner board, but on these boards, which are multi-layer, you're gonna have a hard time with that. Okay, next one. So, this is a 1398. What's wrong with this A1398? Let's see. These screws go with this one. Let's grab another screw holder. Okay. So let's see what this one does. Put this bottom cover up here. I'm terrible with mixing up bottom covers, so I need to be careful about that. Let's see what this does. So this looks like it's liquid damaged. I'm going to unplug the trackpad, the I/O board, and the keyboard. Let's plug it in again. Let's see what it does. So oftentimes, if there's only a little bit of liquid, one of those will cause the issue, either the trackpad, the keyboard, or the I/O board. So let's plug it in. We get a green light. We get no fan spin. Let's inspect near our CPU area. Looks good to me. So now I gotta pull this board out. Maybe we'll get another easy one. That would make me happy. Just like that one night that I was on a roll until 2 a.m. fixing every single one. But it's to focus the heat on just the pins instead of the whole chip. Okay, I can see that. I can see what they mean by that. But a lot of times that on those packages that I've seen, they have a big ground plane too in the center. So the heat really doesn't bug stuff too much. So I've never worried about damaging stuff with heat. I don't think I've ever killed anything with heat. Like a QFN package, a lot of times even if they chisel, they are still fine. So I haven't had a problem with heat. I mean, it can happen if you're real crazy with heat, but it's really hard to kill a component with heat. Now, if the component has electricity running through it, that's an entirely different story. But if they don't have any electricity running through it, then they're usually fine. Tweezers. I learned my lesson pulling on these webcam cables. Never pull on these. Get it with the tweezers kind of and push it out. Yeah, I've pulled on them and it rips all the wires out and you have to buy a new screen and that sucks. Don't do that. Learn from my mistakes. Keep thinking someone's coming in, but it's the wind blowing the door. It's like windy and 100 degrees here. So windy and like 39 Celsius out. It's that hot and windy. I mean, humidity is probably like 1%. Just kills your eyes being outside. What if they have tape over the camera lens doing them a favor? Yeah, but still, I'm not going to leave a laptop with... It's like, how do you approach a customer that way? Hey, I see you have tape over your webcam, but yeah, I kind of screwed up your computer, so I was wondering if you didn't need webcam. It doesn't go over very well. I don't recommend you say that. At all. Let's take the motherboard out. Always forget one screw. We're breaking 66 degrees. 66 degrees sounds excellent. I don't like when it's that hot out, because then I can't go for walks, I can't do anything. When it's that hot out, it just sucks. And it's going to get hotter too. Lovely, no signs of physical damage or liquid damage. Sad. Okay. This is an 820-3662. Let's go over to microscope view. Put this in a slot. Actually, we're kind of full on slots right now, so this is going to go on the customer service counter. Alright, so now that everything, and I could already tell those MOSFETs and those capacitors, that looks like it was burned. That looks like a lot of heat got there. You may not be able to see that on camera, but I can see it. It looks like it got burned pretty good. So let's plug it in. And let's measure PP bus G3 hot. So I know PP342 is present. We have a green light. I saw the SMC reset, so we should be good there. But I don't like the look of those MOSFETs. Can't really feel any heat from them. PP bus is 0.98 volts, and our heatsink is warm. So let's see if PP bus is shorted to CPU V core. Let's see if PP bus is even shorted to ground. Maybe that's warm, maybe it's my hand, I can't really tell. We have a dead short. No, we don't. We don't have a short on PP bus. So we may be just fine. We may be just fine. So let's go over our PP bus circuit. So here's our good old friend the ISL again. Now, what do we see here? See, that resistor looks a little bit hot. That whole area looks like it got a little bit hot. And this actually was replaced. See that? See that? Somebody touched you before. But that doesn't look terrible, that soldering. It just looks like there's not enough solder on those pads. So now we have to figure out what they did. So they heard ISL. Well, we don't know if they heard it. That doesn't look terrible. And they cleaned it. There's just not enough solder there, so it may be just that. Let's check our current sensing circuit now. So let's check current sensing. Resistance mode. So between here and here. Wait, I'm backwards. Move it this way. Here's our current sensing. Three ohms. Our other is right here. 22 ohms, so we're all good. Just for the heck of it, I'm gonna put some solder on these pins. You know what? Let me take that chip off. No, I'll put some solder on those. Maybe it just doesn't have a good connection. That could 100% be the issue. One second here. People are being annoying. People are being really annoying. This is why people are just so pushy sometimes. I really don't. Yeah, I'm ready to. Hey, how's life? Huh? Life is being life. Life is being life. Life will always be life. Alright, you know what? Close messenger window. I don't get the whole idea of being so pushy with no fixes. You know, it's you want it sent back fixed, or do you want it sent back junk? I could do both. I could do both. And I'm not going to put effort into something. You know, I tell people if it's something hard to figure out, if you're okay with it being here for a while, we'll try and figure it out. But if you keep messaging and starting to be rude about it's taking a long time, I'm not going to deal with it. Simple as that. Just go away. Yeah, there wasn't enough solder on this chip at all. There's like no solder there. Should I put? Yeah, you know what? I'm gonna try. Maybe we could save that chip. But yeah, I can't stand the pushiness with no fixes. And this is why I'm never working on PC laptops anymore. I'm sorry, the customers are just they're awful. They're oftentimes awful. I tell them, if please do not send it unless you're okay with an extended turnaround time. It's going to be a nightmare to figure out, especially if it's brand new, like in 2018. What happens every time? One day after it's sent, any update? Any update? Any update? No, there isn't an update. A day later, any update? No. And at that point, it just goes back. I'm sick of this nonsense. So that's why I'm not working on PC laptops anymore. If you send a PC laptop, it's probably going to get sent back, because no matter how much someone begs, I've learned that it's the same thing every time. There is no patience with them. It's complaining, crying, calling nonstop, being rude constantly over a piece of junk that doesn't work. So, yeah, no more. No more. That's the thing, when you're trying to fix something and they're complaining, yeah, just send it back. Just send it back. It's not worth the headache. There are customers that don't complain, that are nice, and that appreciate my work and don't complain and think I'm trying to scam them. So, yeah. DC inboard, need to plug in. I took it out because I didn't want the magnet getting on my on my mat and messing up my screws for something else. Here's our fan. Will it spin? Will it spin? Spins. No, it doesn't. Wait. Are you kidding me? I did that, then it spun and then shut off. Plug it in again. What's PP bus now? It is 11.37 volts, so we have PP bus back. Wait, it just dropped. Now it's at 6 volts. Why is PP bus at 8 volts, 6 volts? But the fan is spinning. And now it shut off. Okay, so when it turns on, PP bus drops significantly, and that, the CPU is hot. I bet this has a dead CPU. Let's see, is PP bus shorted? This seems like a dead CPU. Okay, we have no short on PP bus. What's our resistance or diode mode on V-core? Alright, so PP bus or V-core is absolute 0 ohms to ground. Yeah, 0.5 ohms to ground. That is no good, but here's the thing with PP bus shorts on V-core or V-core shorts. CPUs rarely die to the point where there's 0 ohms to ground. And this is on all phases where it's 0 ohms. Let's see. So we have a short to ground, not a short on it's not shorted to PP bus, but since this was messed with, it could be anything. Let's see again. So V-core to PP bus. No. 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 So we're all good. We don't have a short from V-core to PP bus. So we could have a bad cab. We could have a bad MOSFET. Or this could just be trash if someone tried to... never mind. Never mind. This was attempted fixed by someone. And yeah, this is trash. Or was it? Was this soldered on, you think? Yeah. Yeah. So this was a no fix from someone else. What's this? This is trash, likely, with the fact that yeah, this is trash. So what probably happened, this was probably sent to someone else and then sent to this store where... Yeah, anytime when when PP bus drops like that, something is pulling too much power on the line. And that's what happens. One second, I have to check messages again. Okay, so this is a dead CPU that needs to be reassembled. Another dead CPU. Let's grab another one. Actually, what time is it? 2:54. Actually, it's time for me to go to lunch. So, that being said, I will go to lunch. Or do I want lunch? No, actually I don't. I don't want lunch. Okay, next one. Let's go pick another one. What's next? What will be somewhat... I pick this one. Alright, so this is an A17. Please be an A1708. A1706. Of course it's an A1706. The one I don't want to work on. That never fails. It's the one that's going to be the one that you get is the one that you don't want to work on every single time. Let me grab another screw holder. A1706. I hate these. These are my enemy. There is a chance that it will be easy, like if it's a dead ISL 9239. But most of these are not. So I got one dead CPU and one fixed. Suction cup. What did I... It's up here. Then I need my little pick thing. That's all the way at the bottom of this thing. Come on. There we go. Clamp it on here. I really hate taking these apart. These are like traps, so you will cut yourself if you're not paying attention. Okay. Maybe this will be easy. Maybe this will be easy. So let's plug this in. Let's see what we get. So, USB-C. These have underfilled CD3215s, I think. Maybe not. Maybe this will be easy. I really hope this will be easy. That'll make my day. I kind of both love and hate these. I love that I make more money on these, but I also hate the fact that they're a pain to work on. So here's our multimeter. You can see it right there. Voltage on USB-C is 0 volts. What? 0 volts? What the heck is with that? Zero volts, huh? Alright, let's try another port. So both these don't work. We could have an issue with the port. We will try one of these. And we do get 20 volts. So we do get 20 volts there. Our CPU is getting warm, so this is most likely working. Let's see. It is not. Is this no post? So our CPU is warm. Let's hit power button. I can't see anything on the screen. No fan spin. CPU getting warm? That's not fun. CPU getting warm is something else. CPU getting warm and not posting. Sometimes they take a minute. So let's see, do I have brain? Okay, if I hit caps lock, I get no light. So this has no brain. The CPU is getting warm. Actually rather hot now. So let's close it. Let's check voltage on VCore. If we get VCore voltage, I think it's time that I end this stream, because I already fixed one. No VCore voltage. PP bus voltage. .33 volts. Yeah, this is sad. Okay. Yeah, this one. The fact that the CPU gets warm probably tells me it's dead. Most of our corrosion, I'll show you guys where most of this corrosion is. So most of the corrosion is going to be, my mic keeps moving. Alright, most of our corrosion is going to be right over here, near our USB-C mux. Now this alone, this is why our port isn't working, and that's underfilled, so that's going to suck. This stuff can't really cause no post. That's a sensor. Nothing in that area I would think would cause no post. Most likely what's going on, this is missing VCore from a dead CPU. So it always happens with these. I guess it could be, no, I doubt it. I bet it's just dead. So yeah, I think I'm gonna take off for right now. Oh well, we fixed one. The other one was a dead CPU. This one I'll go through later. Maybe a dead CPU. Another CPU is actually burning hot, which is even more. Yeah, I'm gonna unplug the battery. But that's the reliability of an A1706 after liquid damage. Oh well. It happens. Okay, I'm going to head out for lunch. I better eat before I get hungry. I gotta stop doing that. So, I'm gonna take off. So, thank you for watching.